chapter. Already relations 10 examples are completed. Now take the remaining problems on relations. Now take 11th example. Already 10 examples are completed. 11th. Write in the example. Determine the relation. Determine the relation. Determine the relation. Capital R. Determine the relation capital R in the set. In the set. Capital A equal to set of all 1, 2, 3, 4, 5, 6. Given that this is the non-empty set, is reflexive symmetric, is reflexive symmetric and transitive, reflexive symmetric and transitive, reflexive symmetric and transitive, defined as R equal to, defined as R equal to set of all ordered pair x comma y such that y is divisible by x, y is divisible by x. Find this relation is reflexive, symmetric and transitive. Now see here one by one. In the solution, first write on the relation. Given that R equal to relation is set of all ordered pair x comma y such that y is divisible by x. This is the relation defined on this non-empty set. Next, now find out one by one. First, determine the relation is reflexive or not reflexive. First of all, take reflexive. Now take first reflexive. To define the reflexive relation, what we take? Take one element belongs to the non-empty set. Now take for every A element belongs to the non-empty set capital A. You take the small a or small x in the relation given that elements in the form of x and y, not in the form of a and b. So given that elements in the form of x and y, these two elements, take any one element. Now take first element x. Take first element x. For every x element is belongs to this non-empty set. As reflexive definition is as for every element of x is related to itself. So to find the reflexive relation, first of all write the definition of reflexive relation. This is the definition of reflexive relation. After that, to find this is reflexive or not reflexive, apply this relation on this ordered pair. Given that any ordered pair in the relation, only when pair second element is divisible by pair first element. So any ordered pair in the relation, only when pair second element is divisible by pair first element. We know that x is divisible by itself. We know that x is divisible by x. This is true. Therefore, R is relation is reflexive.
హలో 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 హలో
ఉంటుంది. హలో 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 హలో
హలో హలో
వాళ్ళందరే
హలో మైక్ టెస్టింగ్ 1 2 3 హలో ఓకే సార్ now symmetric relation. Now second one, symmetric relation. To find the symmetric, take for all the two elements x comma y belongs to non-empty set. Symmetry condition is ordered pair x comma y must be in the relation. Already this is given that ordered pair x comma y in the relation only when second element is divisible by first element. So ordered pair x comma y belongs to R only when second element is divisible by first element. Already this is given, and this implies that to find this relation is symmetric or not symmetric, take two elements belongs to this non-empty set A. Take two elements, but two elements must be satisfies this ordered pair x comma y belongs to R. Suppose take two elements are 2 and 3. 2 and 3. Here this what is the relation? Any pair in the relation only when second element is divisible by first element, means first element divides second element. Now take the two elements are 2 and 3. Suppose take two elements are 2 and 3. Here 2 is not divides 3. 2 not divides 3, means 3 is not divisible by 2, means this not satisfies this ordered pair x comma y belongs to R. That's what take two real numbers belongs to A set. Two real numbers must be satisfies this ordered pair x comma y belongs to R. So take the two real numbers are, for example, take two real numbers are 2 and 4, because 2 divides 4, 4 is divisible by 2. 2 and 4, take two real numbers, consider A is 2, B is 4. Now ordered pair 2 comma 4 is belongs to R. Now this 4 is consider y, 2 consider x. Given that elements in the form of x and y, that's why this first element consider x, second element consider y. So this ordered pair 2 comma 4 belongs to R, because 4 is divisible by 2, means y is divisible by x. This implies that now confirm 4 is divisible by 2. Yes, this is true. Now this inverse, take this inverse. Ordered pair 2 comma 4 inverse is ordered pair 4 comma 2. In this case 2 is not divisible by 4. Here 4 is divisible by 2, but here 2 is not divisible by 4. Means here y is divisible by x, but this inverse here this y is not divisible by x. Means this ordered pair 2 comma 4 belongs to R, because 4 divisible by 2. Second, this implies that ordered pair this inverse 4 comma 2, 2 is not divisible by 4, means this is not belongs to R. This not belongs to R. So this y is divisible by x implies that this implies that y is not this implies that y is not divisible by x. And this implies that ordered pair y comma x is not belongs to R, because here 4 is divisible by 2 implies that 2 is not divisible by 4. That's why ordered pair x comma y belongs to R implies that ordered pair y comma x not belongs to R. This indicates R is not symmetric. Therefore, R is relation is R is not symmetric. Relation is not symmetric. Find the third relation. Third, transitive relation. Take third, transitive relation. In the transitive, first remember the condition. The condition is take 3 elements belongs to the non-empty set A. Here given that elements in the form of x and y. Now take in general 3 elements. For all the 3 elements x comma y comma z belongs to non-empty set capital A. But in the transitive 2 pairs must be in the relation. Using the first 2 elements, write the ordered pair is as ordered pair x comma y belongs to R, and using the last 2 elements, ordered pair is y comma z belongs to R. Now this is the condition for transitive relation. So to find the transitive, remember the conditions. This is the condition for transitive relation. After that, apply this relation on this first pair and second pair. Given that any pair in the relation only when second element is divisible by pair first element. So this ordered pair belongs to R. Means pair second element y is divisible by x, and this ordered pair belongs to R only when second element is divisible by pair first element. And this implies that ಗಡಬಡಾಗುತ್ತೆ ಇವತ್ತು ಮ್ಯಾಥ್ಸ್ ಕ್ಲಾಸಿಗೆ ಆಗುತ್ತೆ ನೀನೇನು ಹೋಗಿತ್ತಲ್ಲ ನನ್ನ ಕ್ಲಾಸಿಗೆ